And I have the pleasure of introducing today's first inspirational talk. It's by Kent Larson from the Massachusetts Institute of Technology. And there aren't many places in the world where you can actually see the future, but MIT is one of them. And Kent is a big part of the work that is happening there on the future of cities. He's the director of the City Science Initiative and the Changing Places Research Group at the MIT Media Lab. And they're doing some really amazing work. One thing is modeling. They've devised an innovative way that urban planners and citizens can visualize the impacts of changes in the urban space. That's also called CityScope. So yes, there are two different CityScopes here today. And Kent's groups are really thinking through what it means that so many cities around the world are growing so fast, that billions of people will become city dwellers in the next 50 years. So they're working on very concrete solutions to the challenges of housing, transportation in tomorrow's megacities. And now, please join me in welcoming Kent Larson.
So good afternoon. It's great to be back in one of my favorite cities in the world. I'm going to give you an update of some of the work that we're doing at the MIT Media Lab. How many of you know what the MIT Media Lab is? Okay. It's quite a few. That's good. All right. All over the world, mayors are thinking about how to create innovation districts and promote entrepreneurship. This shows where the venture funding is, and you can see it's mostly on the coasts of the US, Northern Europe, a few cities in Asia, so the world is not flat with respect to innovation. It's actually very uneven. And just for fun, I don't want to talk about politics today, but this is looking at where the innovation in the US is centered, and if you map that to the results of the election that we had recently, you all hear about that? You can see that where the venture funding is centered are deep blue Hillary cities. She lost the election in cities of less than 500,000 people. And I think our challenge is how to bring the same kind of innovation and create opportunities particularly to the smaller cities in the US. We think these are the three key parameters: density, proximity, diversity. There are many others, but in terms of what an urban planner can control, we're working on three systems that support that. One is evidence-based design, new simulation tools, new ways of moving people, we call it mobility on demand, and new ways of creating live-work environments. And I'm going to talk about these three areas and the work we're doing and sort of take you through our journey in each of those areas. And if you do this right, we think the innovation potential will go up in a city, livability will go up, public health will go up, and you'll dramatically reduce resource consumption. So, these three systems, CityScope. So we think of this as real-time, data-driven urban simulation for decision-making and community engagement. One of our sponsors, by the way, is Lego. We like Lego. We like to play with them. We think of Legos, though, as data units, and we can map data to at different scales to these data units. And we started 4 years ago, thinking about how to model cities very quickly using color-coded Legos, where in this case yellow is retail and white is housing, black is office. This was a study we did for a new city in China, 4 1 square kilometer districts, trying to get back to that district pattern. All of these designs use the same number of bricks, basically, but very different parties, very different arrangements, and there's really no way to judge which is better. So we thought we could do better than that. So we then started working on white Lego models where we could use projection, augmented reality. This is Kendall Square in Cambridge, where MIT is. That's the Media Lab. We could then project onto that land use. This shows yellow for housing, mobility modes. We can do simulations like solar radiation, wind flow. These are kind of the easy things to do because there are tools for that, but I'm more interested in less typical data visualization. So this is where all the money is flowing in Kendall Square, and if you see this yellow building right there, that's the Cambridge Innovation Center with 650 startups. So not surprisingly, that's the hot spot in Cambridge of venture funding. Where are young people active? This is a real-time Twitter feed geolocated tweets. You see, sends a tweet, hashtag CityScope. The Media Lab lights up because he was in the Media Lab. You can see his tweet, and we can then do things like develop a heat map of where tweets are sent as a proxy for where young people are active. So if you look at this, Media Lab is very bright. The Artificial Intelligence Lab is really bright. This is the U.S. Government Center for Transportation. You get my point. So we're playing with other tools like, we call this a view cube. You can fly over a physical model and have it's like flying a drone over a physical model, get a view of a virtual model. But then we realized it was too static, too hard to change. So we then started creating these little optically tagged Lego modules. Each one is a database. You can map really anything to each of those pieces, and you can move them very quickly. So just for fun, we took Barcelona. I like the plan in Barcelona. We're working on Andorra. Just north of here, it's another Catalan area. So we abstracted Barcelona. So we took 16 blocks and divided each block into 16 pieces. Each one of those pieces is a database, so you can map different functions to that. And then we can do simulations. Like in this case, we're looking at where the young people are, the millennials in blue, mid-career people in yellow, senior executives in red. And what we're doing now is moving micro-housing and affordable housing from the cheap part of the city up to the top, down into the center of the city, and you can visually get a sense of how these three types of people, categorized by age, are mixing. And we think if you can get that kind of diversity of people mixing at sufficient densities in the right places, you encourage an exchange of ideas. Now, we've been working on these tools for the last few months. So this is an update. I've never shown this publicly. But here, as you move these pieces, you can see this radar plot, and density and diversity is changing in real time as the pieces are moved. And we think these kind of metrics are so critical to think about designing cities. So we took Harvard Square and Kendall Square, where Harvard, University, and MIT, and we mapped them nightlife density. So where MIT is terrible in terms of nightlife density. It's pretty good at Harvard Square. Just the opposite for employment density. We can look at these kind of parameters and try to optimize the city. Now here, this shows moving two different pieces. RS is residential small. Those are micro units. And you can get a visual sense of how the city will change as, in that case, you dynamically tune the density. The buildings get higher for that particular type. And here you can see the mix of the blue, yellow, and red people. So these are all tools we're experimenting with, and actually visual sense of where the population is. In this case, it's segregated, so all the rich people are in one area and all the young, less affluent people are in other areas, not the optimal way to design a city. And we're also looking at conceptual and perceptual views. So in this case, he puts a figure down on the street, and then you can get a sense of how it would be experienced as you make these changes. This is fun. Look closely. So this is a digital virtual mirror, and it actually looks like a mirror, but that's shifting computationally, tracking the eye of the person. So different ways of looking at it. Mobility on demand, that's the other system that we're working on. Alternatives to cars to increase density and vibrancy. These are all the modes that we've been thinking about within that 1 square kilometer district. The most important mode by far is walking. You can have shared bikes, on-demand shuttles. These little boxes in red are the vehicles we've worked on. I'll take you through some of our thinking with respect to these types of mobility modes. So some years ago, we worked on the city car. We got a lot of press for this. It had 4 innovations. It had robot wheels, 1, drive motor, steering, braking, suspension in each wheel. 2, it's drive-by-wire like a modern airliner. Get rid of useless things like engine and transmission, so the chassis is unencumbered. You can fold it, number 3, so it occupies very little space, and the front door opens. You step directly out on the curb. You can see you get 3-to-1 in a parallel parking scenario. We like to build things, so most of what we do involves building prototypes and then modeling their impact on the city. So this is the city car. You see it had a yoke. You can pivot it left and right, drive it in London and Paris the same day. Then about that time, I realized it still was a car, and I wanted to get rid of cars in cities. That's now our mission, not to design a better car, but to get rid of cars. So we decided to design a little three-wheel vehicle that would democratize access to bike lanes, so more than just young men would use bike lanes. So this was three wheels, it was stable, you could use it if you were disabled or elderly or wanted to be protected from the rain. And that was fine, except it still was not combining the three features that I think are critical for personal mobility systems: autonomy plus vehicle sharing plus electric drive. Now, around that time, this was a couple of years ago, the cost of the sensing and processing for autonomy was declining at a dramatic rate. These are MIT projects that went from $100,000 to now what we're doing for about $500. Car companies are up here. They're thinking about full autonomy driving in all conditions. That's maybe 8 years away. We decided to focus on driving in bike lanes because we can do that today. We launched our new, what we call Persuasive electric vehicle at the Consumer Electronics Show last January. We made it look very gentle, almost like a baby buggy, because it would interact with people in a way that wasn't frightening and scary. The features of this was it's bike-like, not car-like. It's legal in bike lanes, not roads. It operates at walking to bicycle speeds, not car speeds. It's low-cost autonomy, not expensive sensing and processing. It's shared use, not privately owned, and it moves both people and goods. Those are the essential features. So we, as I said, like to build prototypes. In this case, it uses a vision system to recognize the lanes. It's like a driverless bike-like Uber system. The idea is you call for it to come wherever you are. You can then get on it and drive it to your destination and just get off wherever you want, and it goes on its way to pick somebody else up. Or you design the fleet to serve people at peak hour, and off-peak, then it can move goods. We prototyped this just north of here in Andorra. What was it? Last month, I guess it was. And so here is in one of the plazas in Andorra. We also showed how, in this case, a couple could go for a stroll and the vehicle just follows them like a puppy dog. So moving people that's really key, but also moving goods is critical. So then we thought, well, the transformation in this case is from a people mover to a goods mover. And we have now a new project to try to really flesh out what that might mean for cities. Now, back to Kendall Square where I work. Everything in red here is a parking lot. I mean, it's amazing how much land is wasted to parking. It's a complete waste of a very scarce resource. So we modeled what would happen with private cars. So the private cars, you need all this parking, but when you move towards shared vehicles, you can provide mobility with maybe a third fewer vehicles and get rid of half the parking. So everything that's now gone white from red can be used for housing or commercial uses. But the big advantage is when you go to shared autonomous vehicles, because then you can essentially get rid of all the parking and reduce the total trip time for the individual and serve the population with maybe a third fewer vehicles. So we, just for fun, took a parking lot in Kendall Square and we said, what would happen? Well, it now had 45 cars if we built a micro-housing apartment building at the legal height limit in Cambridge, and you could replace 45 cars with housing for 528 people. Let's talk about that a little bit. That's our City Home project. Hyper-efficient housing to increase density and affordability. Affordability in many cities, the cities where young people most want to live and work, is becoming out of reach. And by the way, this just shows San Jose and Millennial would have to make an additional $80,000 per year to afford an entry-level house in that city. So former Mayor Bloomberg of New York was advocating very small apartments, micro apartments, in this case a 300 square foot apartment, 29 meters, and it had a pull-out sofa bed that you had to take the pillows off and change it every day, almost no storage. We did a little experiment in our group. I said, let's make it 1/3 smaller, 200 square feet, but make it function as if it was 3 times bigger. That was the challenge to the students. So instead of a little double pull-out sofa bed, we had a queen-size bed. And by the way, I said, easy's not good enough. It has to be absolutely effortless and magical. And so in this case, we have automated transformation using hand gestures and touch sensors and voice and different things. So we have a office with a 6-foot desk, a dining room for 6 people, a living room for 6 people, a very small bathroom that opens up to a large bathroom for getting ready for a party, or if you are wheelchair bound, the kitchen counter doubles in size. And we put this out on the web. We got about 1 million views in the first couple of weeks. And we had developers call us from all over the world. So we said, well, this is a big idea. We need to launch a company. No company makes these solutions. Developers can't do this if they want to. So we launched this company. We took a subset of those ideas, and now we're making commercial products. In this case, this young woman wakes up, her bed just goes away. She doesn't even have to make it. She has a bedroom and a living room, but the bedroom collapses to make a very large living room, and she just goes about her life. So we wanted to show that just like our autonomous vehicles, having architectural robotics in an apartment would be very natural, just as natural as just opening a door. These are the kind of products that we've been developing with an interface. It has presets so you can hit living or dining or sleeping or dressing. We're also looking at how to understand fine-grained behavior in the home. We have little sensors that we built. They're called MIT environmental sensors. This is the 3rd generation TER, so we call them termites. In this case, we can sprinkle these little sensors around an environment, and they're just using here a tablet to recognize what the sensor data flowing from that sensor is. What do we do with this? Well, we instrumented an apartment in Sweden that IKEA owns that has two of the moving walls. Every little dot here is a sensor that we have on every cabinet door and faucet and appliance, etc. The bouncing ball shows the sequence of sensor activations. The yellow dots with a big circle around it shows many activations. If it has no circle around it, it was never opened. This helps us understand these patterns of activity so we can optimize these environments. All right, last thing I want to talk about. We, in our group, believe in getting things out into the world. We don't like projects to just remain purely academic. These are the cities that we have a relationship with currently, and I'll just show you a couple of them. Riyadh was the first city that we worked with in Saudi Arabia. They were redeveloping a roughly 1 square kilometer district. We built a little tool that could look at walkability, energy consumption, and daylighting. We took 20 urban planners from the Riyadh Development Authority, divided them up into 4 teams of 5. Each had 1 hour to design this district. And here, the interface was really simple. It's just red is bad, green is good. And as you move the pieces and toggle through the different visualizations, the different algorithms, you can then converge more easily on a solution. That was quite effective. In Boston, we focused on community engagement and decision making. If you've ever been through a community board hearing where there's a controversial issue that's being reviewed, this tends to be the dynamic, very contentious. We thought we could probably do better. In this case, there were 5 routes that were proposed for bus rapid transit, sort of a cross between a subway and a bus. You have a station that you enter into, go through a turnstile, enter on grade to the bus. They're dedicated lanes. It moves very quickly. The bus people love this. The car people hate it. So it's very controversial. So we built 3 platforms at a regional scale, community scale, and street scale, and we did workshops with the community, and we allowed them to play with these tools, and this kind of data was updated in real time so they could get a feel for the impact on parking spaces and traffic flow, etc. The touchscreen actually didn't work. It was too complicated. Here, you had menus. It was a very powerful tool, but it wasn't good for the community engagement. This worked well at the neighborhood level, little Lego pieces that people could move and play with, and the routes would be updated as they moved the station locations. And the street scale, where you could have the stations on either side, which is not quite as effective. or the gold standard with the station in the center, replace parallel parking with bike lanes, and it was quite effective. I think maybe the project where we've had the greatest impact is in Hamburg. As you know, that Hamburg and many European cities are being hit with an influx of refugees. We work directly with the city to try to identify sites for housing for as many as 80,000 refugees. And the mayor had 3 criteria. He said, every district needs to share equally, no ghettos, the refugees need to be evenly assimilated, and the city was not going to dictate where housing was built. This had to be a bottom-up process coming from the community. So in this process, people would work at one table. They'd put these Zoom rings down over the areas they were interested in. The maps were all color-coded by environmental regulations and zoning and land use, things like that. That would then zoom that window into the second table where we have our optically tagged Lego pieces. And then the community would experiment with different locations of these number of units on the table. It was very positive and very interactive. And I think whereas virtual tools put people in echo chambers, when you come face to face and have to address a problem with your fellow citizens in the community, it leads to a much more positive engagement. The community has identified something close to 150 sites. The city has vetted something over 30, and something approaching 10 are under construction. We're now working on a detailed exploration of one particular creative community for entrepreneurial immigrants and creative Germans. By the way, The Atlantic called this Germany's radical pro-refugee urban planning experiment. It didn't seem too radical to me. It seemed quite obvious, but I think compared to the conventional urban planning process, it probably is quite radical. We've had a fantastic time working with the people in Andorra. I know all of you from Barcelona know all about Andorra. This is the capital. We're building a large CityScope model of Andorra, and we have extraordinary data. We have 3 years of telecom CDR data, energy data, transportation data, and it's allowed us to do some really interesting work on identifying these complex patterns of behaviors and working with the people in Andorra to try to think about the future, urban design, new mobility systems, et cetera. That's the CityScope table. This just shows one visualization of the data during Cirque du Soleil. This is a traffic jam coming from Toulouse. No traffic jam in St. Julia coming from Barcelona. And this is the activity Cirque du Soleil, showing Spanish people in orange and French people in blue. And very quickly, Jerusalem, what we're doing. We did a workshop there. Jerusalem, series of hilltops. They're landlocked. They need to go up. They're growing. They can't expand because of political and other constraints. So we said, well, what if these neighborhoods that are on top of the hills only had 3 modes, had walking, PEVs, and dynamically routed shuttles? What could you do? Well, you could get rid of curbs, wide streets, parallel parking. If you added our PEVs and shuttles, you could expand the people space and increase the density and basically have the good without the bad. Okay? So, anyway, I do a lot of these talks. I go to a lot of conferences. They have names like Smart City and Green City and Eco City and things like that. And it's all good. But I think the things that we care about are how to create a more entrepreneurial city, which is about jobs and GDP, how to create a more livable city, which is quality of life, and how to create a more high-performance city, which is about how efficiently you use resources. And I think the main thing that we want to focus on, even though if we're from MIT, which some say is the center of the universe of technology, it's not about the technology, it's about people. Use technology in the service of people and design cities for people, not machines. That's my message. So thank you.